We've got our two rails done and our front cross member. We have our rear cross member, our rear axle support, and our front gussets to do. So let's get over to the plans. Part number 3, we need one of 127 millimeters long. Part number 4, we need 2 of. Each end has a 45-degree miter joint and it's 130 millimeters long. Narrow end standing up, 45-degree cut, and then we're going to measure from the long side 130 millimeters. So the very first thing we're going to do is a 45-degree cut. Our bandsaw is currently set for a 90-degree square cut. We need to modify it so it's a 45-degree cut. Release your base plate, swing it around, and lock it in position. Now part number 5, we have 2 of 220 millimeters long, 45-degree miter cut on each end. Later on, we'll be drilling the holes. We've done our first mitered cut at 45 degrees. We now need to measure 220 millimeters long to then do the other end of our miter. Now part number 6, 2 of 140 millimeters long, 45-degree miter cut on one end, square on the other. The next part is number 7, 1 of 45-degree miter cut, 45-degree miter. This is our final part, part number 9. We need 2 of them, 545 millimeters long, 13 by 13 square tube, 1.6 wall. Now we've got these pieces done, let's see what's next. We're up to part number 10. We need 8 of. These are the brackets that mount the timber rails for the tray. With our side bracket mounts, we need to cut them 25mm wide by 52.5 long. So we'll measure and mark out our cut. Then we need to do a double fold and a 4mm hole. Our side brackets are made out of 1.6mm cold rolled deep drawn steel. To cut it, we can't use tin snips. We're going to need to use something a little bit more powerful. Heavy duty guillotine, we can use our bench mounted shear, or we can use our power tools. Now we've got our side brackets cut out, we need to measure and mark where we're going to start doing our fold. The fold is a double fold, it's a Z section. It's a little bit tricky to do, so we can use our vice mounted brake press jaws. Another way to do it is to set it up in the vise, just using hand tools and hammering it over. We now need to do a 4mm hole in one face only. Now we've drilled our hole, we need to then take the radius off and dress it so we don't have any sharp edges or burrs. Part number 11, we need 4 of. It's a 90-degree fold with a 4mm hole, 60mm by 25. Part number 12, we need 2 of, 4mm hole, 90 degrees fold, 70 by 19 millimeters. Now we've done our side mounting brackets, we can move on to part number 13. It's a crank base plate. We're making it out of flat bar, 40mm wide, 5mm thick. We need to cut 3 sections. We have to drill and slot 4 holes, and we've got 2 welds. We need to measure and mark 3 sections, 2 at 200 mils and 1 at 70 mil long. We've got our 2 sections at 200 millimeters long. We now need to come in from one side 23.5 millimeters. That's to allow the chassis rail to sit on top of our crank base plates. So we mark our 23.5. Then from one end we come in 60 millimeters, then 80 millimeters from the 60. That will give us our hole centers. Measure and mark 10 millimeters here, and then 10 millimeters on the other side. We're ready to start drilling our slots for the crank plate. So the first thing we have to do is position our piece correctly in the vise. We also have a sacrificial piece of timber, and we use that for two reasons. Number one, we're elevating the piece closer to the drill bit, so there's less vertical movement. Number two, if we do drill through our piece, we're not then going to drill into the vise, and the piece of timber, obviously being soft, it will allow the drill to drill in, and it also holds it quite square. You also need to clamp and position your vise correctly, because the piece that we're drilling, if that accidentally grabs on an edge, what will happen is it will also rotate in a clockwise direction and either A, injure ourselves or damage the piece, etc. And don't forget, we've got safeguard. That has to be closed before we start the process. We've drilled our 6 10mm holes. We now need to draw our flats so that we can then get our adjustment in our crankbase. Then what we can do is set it up in the vise. We can use our deburring tools, or we can use a round rat tail file and finish it with a flat file. When we go to slot our elongation section, we're going to use an air tool. We do need to oil it, okay? Just a few drops of oil in here to begin with, and also at the end. If you have any moisture in your airline, what can happen is you can get corrosion down inside the machine and the vanes will jam. Then the machine is no longer usable. We're using a carbide cutter, and you can see in this set we've got multiple carbide cutters. The fine teeth are for steel. You can also buy them in coarse for aluminium. So we've used air tools, we've used hand tools. The other way that you can go about doing this is setting it up on a mill and do a slot cut. You can do it with water jet, plasma, or laser cutting. We have our base plate cut, holes drilled, slotted. Don't forget, we've also got a wider offset, so the chassis rails will sit on top. We're going to use a welding table to set everything up nice and square to control distortion with a spacer plate, or you can use a steel plate on a workbench. We're set up now and we're ready to weld. I've also used risers to get the piece up off the workbench because we're going to need to weld on both sides. Our MIG welder is set to our 5mm material thickness. We've finished our base plate. I've dressed the welds, so let's start looking at part number 14. Part number 14 consists of this template that we cut out. It's made to scale. It's going to be out of 1mm mild steel. We've got some holes that we need to drill, relieve on the corners. There's also a fold sequence that we need to follow, and there's 4 welds that we'll do. Before we start doing anything, we'll need our 1mm cold rolled deep drawn steel. Your steel merchant refers to it as 0.9 or 0.95 material. We also have 2 options. Number 1, you can download a DXF file on a USB and take it to your laser cutter. He will cut everything out of this 1200 by 1200 sheet, even holes, pre-cut slots for your louvers, all the attention to detail that will save you hours and hours. Option 2 is we'll do everything by hand. We'll cut the individual templates out, overlay them onto our steel, mark our hole centers, our fold lines. We suggest you buy a whole sheet, however, if that's impractical, get some measurements off the plans and buy the smaller offcut sections to match. Now we've got our template cut out, we can mark around the perimeter, but we also need to mark and center punch our holes, the ends of our fold lines, and also our reliefs, so that when we fold the edges, you won't get any puckering or kinking on the corners. I'm going to drill out our relief holes. They're 3 millimeters. The side holes are for our firewall and also the steering column. That's 7 mil. Now we've marked out and done our holes for our folding and mounting points. We need to cut it. We can use a guillotine, we can use bench shears or a power cut-off saw. However, 1 mil is really good for tin snips. Tin snips, there's a trick to it. Right-handed means that the waste will go up and away to the right. Left-handed, the waste goes up and away to the left. You can see they're also coloured. When you're using tin snips, a good idea is to cut using approximately 90% of the length of the blade. Don't cut all the way to the end, otherwise you'll get a very sharp burr. If you run your finger over it, what will happen is you'll get a syringe cut and you'll end up bleeding. We're going to use our bench shears to do the major trimming, then we'll use our tin snips to do the final detailed parts, and then just to burr it with an engineer's file. Now we've cut it out, we've done our holes, we've also got our fold lines. Fold 1, 2, 3 and 4 come inwards. Folds 5 and 6 reversed or outwards. We're ready to start folding our steering column mount. We can use our vise and manually do it with this range of hand tools, or we can also use our vise mounted brake press. We can also use our folder pan brake or an electromagnetic pan brake. Let's demonstrate a few ways on how we're going to fold. We can do this in the vise using a block of timber, a heavy hammer, and working from the back to fold it over. It'll be effective, it'll get the job done, but it's not going to be the neatest way of doing it. You can see here over the vise, we're getting a slightly sharper line than where it's not supported. So we'll have to move it along in increments to make sure we get a good consistent fold line. With these vise mounted brake presses, you can remove the finger to customize the length. It's also magnetic, so it helps attach quickly. And it will give you a 90-degree fold once you apply enough pressure. Make sure you've got enough clearance on the vise. We're up to fold 4 now, depending on the equipment and the machinery that you've got as to how exactly you would finish it off. But folding in sequence, we can use a little bit of off-cut 5 mil flat bar to use as a folding surface. It's a 50-degree angle, so however you get it, it's variable. The tabs also have to line up, so we'll need to do a little bit of correction work. Just a simple pair of pliers or sheet metal folders, hand tools, hammer and dolly. We're going to do all 6 folds on this machine. It's a 4-foot pan brake or loose leaf folder. We can customize removing individual fingers to suit each length application for each fold. On this machine, we may have to vary our fold sequence a little bit on the last couple of folds. When you clamp the top blade over the job in relation to the bottom blade, what you've got to make sure is our fold line is directly underneath the clamping point. You've got to allow for a little bit of movement when you do clamp it down. Make sure your fold line is directly over the fold point for the lower bed to come up and fold 90 degrees. You have to overfold it slightly to allow for spring back. This one you will only be able to go to 90 degrees because it will stop on the back face. Allow some offset so that the back folded piece, when it comes up at an angle, doesn't bang in or bend this back fold. So just allow yourself about 10 or 12 millimeters of offset. We're just going to tidy up these faces a little bit because we've got a weld coming up shortly. Get the surface nice and smooth and level. I've just done 2 small welds here to finish this piece. Now we've got our parts cut and prepped, let's weld it together. We've got our rear axle subframe here. This is square and ready to weld. We've got our front cross member. It's upside down because we need the top of the steering arm pivots to be flush. It underhangs on the bottom side, and the steering arm pivot has to have any galvanizing or zinc-anneal removed so that we have no contamination as far as the weld, and also fumes. Before welding our front cross member, we need to make sure we've got 525 millimeters between our hole centers. Also, the center of the rectangular tube is in line with our steering arm pivots. Everything needs to be square and flush. If you don't have a welding table at home and you're using a workbench, please make sure that you tack everything, check it's square prior to final welding. We're ready to weld all the components together. We can do it on the workbench, trestles, or the welding table. With our workbench, we've laid down a safety welding blanket. We've also raised it off the workbench, so we're trying not to damage the surface. We've used a lot of clamps in this process, and we've spent a lot of time on setting up everything to get it square. You can actually see that we've shimmed this part here to get this level with the front to make sure that we don't weld a twist in it. Now we've got our chassis set up on the welding table. We initially started with squaring up the rear cross member for the rear axle onto the table. The advantage there is we've used these locating pins to get the cross member perfectly square. Then from the datum point, we've measured 305 millimeters to the back of the rear cross member, 941 millimeters to the back of the crank base plate, and 1,480 millimeters to the front face of the cross member. We had to open up the tolerances of the front cross member to allow for any diagonal misalignment. So that way you can get everything square. Initially, we just simply loosely clamped everything so we could allow a little bit of movement backwards and forwards. Then once everything was square, we gradually went around in sequence and tightened everything up, including using our F-clamps. The sequence to welding our chassis is initially we're going to tack. We're going to tack from top face to bottom face and work our way systematically around from point to point. Then we'll come back and we'll stagger the welds. We'll work from one to another, gradually working our way in sequence like you're tightening a cylinder head. That will help control the distortion. Ultimately, we're going to turn the chassis over and weld the bottom side that we can't get to for now. Now we've almost finished welding the majority of the chassis. You've got to make sure that there's not too much temperature in the welds, so keep the clamp pressure on while it cools down. Then you can start to release your clamps, and that will then allow you to use reference measurements to set up the next lot of components that we're going to have to weld on the chassis. Now we're setting up our gusset supports for our front cross member. There's only one position they'll sit in with a mitered 45-degree cut. We've done our two front crossmember gusset supports. We're now up to doing the outriggers. The rear outrigger helps hold our rear guard, our running board. The front outrigger is also a bolting point or a mounting point for our firewall and the front of our running board. I've intermittent welded this part because there's a small 3mm gap between our mount and the frame, so just carefully weld through that area. The reason we have to be so accurate is because our firewall mounts directly to that face, and as you can see it slides down. It's got to be nice and square, offsets, so you've got to be quite accurate in getting everything correct. These are parts 10, 11 and 12 for our floor mounts. Also our timber rails, the beds. There's 7 pairs of brackets. Everything has to be measured from our datum point and it has to be true and square to each other. We've squared up the back of our chassis rail. Make sure that your end cap sits over the end of the tube and it's level. This is exactly what the tabs are for, to mount your bed. So we're mocking this up just to give you a visual. So we've 90% finished our welding. We just have to flip it over and finish off a few very minor, finer points, etc. everywhere that we couldn't get to from the top side. We're going to measure and mark out our holes for our bearing blocks for the rear axle. It's really critical that we do this square to the chassis rails, because if we're out slightly as far as our dimensions on our rear cross member, then it will crab, it won't steer straight. Our bearing caps are 80mm from hole center to hole center. We also measure out 102.5mm from the vertical face of the chassis rail. There's 2 holes on each side. That gives us 370mm from hole center to hole center. We've measured, marked and center punched our hole centers. I'll do a pilot hole at 4mm. Ultimately we're going to run through with a 10mm drill bit. We're up to part number 8. It's 2 M6 nut certs. 58 millimeters forward of the front cross member. It's to hold the front radiator shroud. The width of our rail is 19 millimeters, so half of that will give us our center. Then we're going to center punch. From there, we do a pilot hole, 4 millimeters, then 9 mil, so that we can then insert our nutsert. We've used a steel nutsert because the gripping strength is better than aluminium. We've measured the OD with our verniers. It's 9 millimeters, so it's a 9 millimeter hole, and it slips straight in. We've got a finished chassis now. We've measured, marked, cut, welded, distortion control, used a bandsaw, we've done nutserts, lobster backing, sheet metal work. So we've covered a lot of skills. I hope you've enjoyed it so far. This is the end of Plan 1. We'll see you for Plan 2.